Hey, AP Chemisters, this is Mrs. Vanderlei bringing you Blankwalle 17.5 Part 2. So we left off looking at how Gibbs free energy will determine whether a reaction is spontaneous or not. And now this section here of your notes, we'll do some math problems and we'll actually see how this all works. And the answer to part B is also going to be really important when we get there. So let's look at what's happening here. We're going to decompose carbon tetrachloride into carbon and two chlorines. What do you know about delta H? It's endothermic. What else do you know about delta S? We go from a gas, 1 mole of gas, to solid, which isn't too hot, but you make 2 moles of another gas, which is better. So you are increasing the entropy. And what did I tell you earlier? That the signs are the same, so it is temperature dependent. Okay, so what we're trying to do in letter A is, well, at 25 degrees, is it going to be spontaneous at that temperature? So let's find out. We are going to have, whoopsie, sorry about that, delta S is going to be, or delta G equals delta H minus T delta S. I am going to plug in the values, okay, and here we go. Notice something when I do the math here. When I subtract, what's my unit as I wrote it? Oh, be so careful here. This is in, well, the kelvins cancel out, but this is in joules, isn't it? This is in kilojoules. So what must I do next? I have to convert joules into kilojoules, and how do I do that? If you said divide by 1,000, you're right. So that's my next stop, is to convert my joules into kilojoules. So it's 0.1422 kilojoules. And then when I do that, I get a positive 52.9 kilojoules. And at 25 degrees Celsius, it is not spontaneous because delta G is a positive. So like I said earlier, when we have a positive and a positive, let me scroll back to the prior page. So in case number letter D, when we had a positive and a positive, when will this thing work? Well, here is our thing. We start off at a positive delta H, and we need to drive this past 0 into the negative. So when I determine what temperature is, all right, I will find that break-even point where delta G is 0, and any temperature greater than that will make it work, okay? So at low temperatures, I'm still in the positive range. I need a higher temperature to push it past the delta G is 0. And if you continue to look down here, when I had both positive and positive, what did I say here? It depends on the temperature, and temperature needs to be high. So let's kind of go back and make sure that makes sense to you in this problem that we're working on. Let's go back to the next page here. Do you remember that number line? I'm going to make delta G 0. All right, so when I determine this temperature, I know that any temperature higher than what I'm going to solve for will make it spontaneous. All right, so if I do that, I'm going to add T delta S to both sides, so I get something like this. Well, I want to get T by itself, don't I? So I'm going to divide both sides by delta S. Well, here we go. Oops, I kind of left out my kilojoules here. So it should be 95.7 kilojoules divided by the 0.1422 kilojoules per Kelvin. So when I figure this out, then my answer is in Kelvin. And so what does this temperature tell me? This is my 0, when delta G is 0. So any temperature higher than this, it will be spontaneous. And how else might I think about this? It was not spontaneous at 25 degrees Celsius or 298 Kelvin, which is lower than 672. So that means any temperature higher than that will work. So in answer to this question here, it says, if the reaction comes or is not spontaneous, determine what temperature, if any. So any temperature greater than 672. At 672, delta G is 0. It is still not spontaneous. The break-even point is where delta G is 0, so any temperature above that is going to be spontaneous, okay? Well, let's look at the next question, very similar to this one. Consider this reaction. We have ethene plus hydrogen making ethane. delta H is negative and delta S is negative, okay? Ooh, they're the same signs. What did I tell you earlier? If they're the same signs, that it is temperature dependent. So let's go ahead and figure out what delta G is and then determine at what temperature is your break-even point. So why don't you go ahead and pause this, and I mean it, work through this on your own, and then come up with an answer. So pause this, please. All right, we'll try this again. So we're looking at case letter C right now, where both of them are negative. And so what did we say here? If I have a temperature that's low enough, it will remain delta G is negative. And then if it's big enough, then it is going to be positive and won't be spontaneous. So at delta G equals 0, that's my break-even point. So keep that in mind. So we're looking at low temperatures, right? For this to be spontaneous. So if I look down here again, when they're both exo, low temperature. Let's take a look at problem that you're working on. All right, so delta G equals delta H minus T delta S. So I plugged in some numbers. Don't I have a little problem here, don't I? Because this is still in joules per Kelvin. So I do need to convert that into kilojoules. And when I do that, I get a negative 101.6. So guess what? At 25 degrees, it is spontaneous. Woohoo! All right, so now what? At what temperature is it no longer? So I solve for delta G to equal 0. Therefore, we have delta H is equal to T delta S. Therefore, T is equal to delta H divided by delta S, all right, to get solved for T by itself. So here's my values. Notice what happens here. My negatives cancel out, and I get this value. So that's a pretty high temperature though, isn't it? Sure is, but what is that T at 1149 Kelvin? That's your break-even point. So what did we say earlier? Any temperature less than this, it will be spontaneous. And does that make sense? Is 298 right here less than 1149? Yes, it is. It was spontaneous at 298, which means, again, any temperature less than 1149, it will be spontaneous. Okay, let's look at problem number 7. All right, so this is a very common, multiple choice question, hint, hint. All right, so it says, which statement is true about the sublimation of dry ice? All right, what does sublimation mean? You're going from a solid to a gas. All right, first of all, what's delta H? Does it require energy or does it release energy? So if I start from the bottom solid, move up to a gas, delta H is positive. It's endothermic, it requires energy. So if you're looking at your choices here, automatically B and D are out, aren't they? Okay. Oops, I'm trying to cross that out. There we go. Now what? We're going from a solid to a gas. So what is delta S? If I go from a solid to a gas, delta S is positive. That's right. And so delta G is going to be positive at low temperature and negative at high temperature. And that's true. So if it's too low, dry ice is going to remain dry ice, all right? If it's negative 44 degrees Celsius, then it's still remaining a solid. It has to be higher than a certain temperature for it to work, and therefore delta G will be negative. Okay, so problem number 7 is correct, or A is correct. And that's all of section 17.5. I hope this went well for you. And once again, I'm going to leave you with these words. Don't wait to be great. See you next time. Bye-bye.